A raft of mass 180 kilograms carries two swimmers of mass 50 and 80 kilograms. The two swimmers simultaneously dive off opposite ends of the raft, each with a horizontal velocity of 3 meters per second. With what velocity and what direction does the raft start to move? So this is just another example of conservation of momentum. Let's draw the raft. And the two swimmers on the edge. Now one of these swimmers is 80 kilograms. The other, 50. The mass itself the raft itself is 180 kilograms. Now intuitively you may be able to guess which way the raft is going to move here. But let's prove it through the same analysis that we had done in the previous problems. The raft is just floating at the start, so its velocity is 0, and the total momentum of the setup at the beginning is 0. But we need to add up all the final momentum. So there's the mass of the 50 kilogram person times their velocity. There's a mass of an 80 kilogram person times their final velocity. And then there's the mass of the raft and its final velocity. Now we can plug in everything except for the final velocity of the raft, and that's what's going to allow us to solve this problem. You want to consider the direction when it comes to momentum. So the person who has the 50 kilograms, they're going to jump off to the left. So let's give them a negative 3 meters per second speed. Whereas the 80 kilogram person will have a positive 3 meters per second. And we just have to solve for that final velocity of the raft. Let's plug it into calculator and see what we get. It's a final velocity for the raft of negative 0.5 meters per second. So the push of the 80 kilogram person actually wins out compared to the push of the 50 kilogram person.